Welcome to Vrindavan Greens, where we transform your empty spaces into beautiful, eco-friendly, and relaxing environments. Transform your dream garden into reality with us today.
If you've ever planted a summer garden, chances are you've stood out there with a hose or set up an oscillating sprinkler and just let the water rain down over the whole yard. But spraying water through the air is incredibly inefficient. A huge percentage of it evaporates in the heat before it even reaches the ground, and a light breeze will blow another chunk of it right onto your driveway. Even the water that does hit your garden can cause problems. Soaking the leaves creates a perfect breeding ground for fungal diseases. Plus, that wide, shallow surface watering encourages plant roots to stay near the surface, leaving them weak and stressed when the soil dries out. In the late 1950s, farmers in arid environments, specifically in Israel, realized there was a better way. They found that plants actually thrive when water is delivered slowly and directly to the soil. This led to the development of modern drip irrigation. It is an engineered, low-pressure sequence of components designed to deliver moisture precisely to the root zone, drop by drop. To understand how this works, we have to follow the water, starting right at your exterior house faucet. The municipal water coming out of this tap is highly pressurized, meant to push through the plumbing of your entire house. Before we send that water into the garden, we have to attach a hose vacuum breaker. This is a crucial safeguard. If the city water pressure suddenly drops, this one-way mechanical valve snaps shut, stopping dirt, fertilizer, or stagnant puddle water from siphoning backward into your home's clean drinking supply. Right below that, the water passes through a Y filter. This contains a fine 200 mesh screen designed to catch microscopic grit and mineral flakes that could easily clog the tiny openings down the line. Finally, the flow hits the pressure regulator. Standard city water pressure will blow a drip system apart, so this component restricts the flow, stepping it down to a gentle, steady 10 to 20 psi. Alternatively, you might choose to bypass municipal water entirely and hook your system up to a gravity-fed rain barrel. Because a rain barrel relies solely on gravity, where water flows downward and outward until something stops it, the pressure is naturally extremely low. As long as your tubing stays below the water level in the barrel, you can skip the pressure regulator altogether. Whether you start at a city faucet or a rain barrel, the critical first step is exactly the same: taking chaotic, high-volume water and taming it into a manageable, controlled flow. That tamed water now enters the main line. This half-inch black tubing acts as the distribution backbone, carrying water across the length of your garden beds. You can customize this layout by cutting the tubing and inserting T-junctions. By adding control valves at these intersections, you dictate exactly which zones of your garden get water and which stay dry. From there, the water reaches its final destination, the emitters. These tiny valves are placed at specific intervals to match the exact spacing of your crops. If you're growing corn, for example, you can place an emitter every 6 inches. By only releasing water exactly where the cultivated plant is growing, the soil between the plants is left completely dry. Without surface moisture, weed seeds in those empty spaces simply can't germinate. When the water finally emerges, it doesn't pool on the surface. It forms a slow, heavy drop that seeps directly downward, navigating through the soil particles straight into the root zone. Because the entire network is made of flexible polyethylene, you can tailor it to fit around established plants. You can spiral the tubing specifically around the base of a mature tree, ensuring its entire radial root system gets soaked. By delivering water point to point, the physical layout of the tubing perfectly supports the biological needs of each plant, while cutting out environmental waste. However, this precision does come with a specific vulnerability. Because drip components rely on tiny internal chambers and narrow channels, they hold small amounts of water even when turned off. If the temperature drops below freezing, trapped water turns to ice. It expands with enormous force. Rinse off the mesh filters. I make sure your emitters are staked 4 to 6 inches away from the base of your growing plants to prevent stem rot. By taking a little time to set up this linear, low-pressure network, you can harness basic fluid dynamics to your advantage. It saves money on utility bills, preserves local water resources, and cultivates a healthier garden.